In 1a, we need to find the first 4 terms in the expansion of 1 minus 1 over 8x to the power of 10, giving each term in its simplest form. So we need to apply the binomial expansion. We start with 10, choose 0, 1 to the power of 10 minus 1 over 8x to the power of 0. So we start with the full power loaded on the first term and a 0 power on the second term. Then it's 10, choose 1, and we've got 1 to the 9 times minus 1 over 8x to the power of 1 plus 10, choose 2, 1 to the power of 8 minus 1 over 8x to the power of 2 plus 10, choose 3, it's 1 to the power of 7 minus 1 over 8x to the power of 3. So each time we drop the power of the first term by 1 and we increase the power of the second term by 1 so that we always add up to 10, the original power given. If we plug this on the calculator, we get 1 minus 5 over 4x plus 45 over 64 x squared minus 15 over 64 x to the power of 3 plus dot dot dot. These are the first 4 terms in the expansion. In part B, we are asked to find the coefficient of x cubed in the expansion of 3 plus 10x times 1 minus 1 over 8x to the power of 10. So I will start by writing out the expansion we obtained from part A. So we've got 3 plus 10x, the first bracket, and the second bracket expanded. The first few terms are 1 minus 5 over 4x plus 45 over 64 x squared minus 15 over 64 x cubed. Remember, we're trying to determine the coefficient of x cubed, and we need to figure out which combinations will give me an x cubed term. So we've got the constant times the x cubed term and the x times the x squared term, giving me an x cubed term. So this expansion will be dot 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 plus 3 times the minus 15 over 64 x cubed plus 10x times 45 over 64 x squared plus dot dot dot. I simply ignore the other terms. So this is giving me dot 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 minus 45 over 64 x cubed plus 225 over 32 x cubed plus dot dot dot. If I combine these together, I get 405 over 64 x cubed plus dot dot dot, and therefore we conclude that the coefficient of x cubed is 405 over 64. Be careful here not to include the x cubed term. When we talk about the coefficient of x cubed, we refer to the number and the sign in front of x cubed. In question 2, we've got the curve with this equation shown on the graph here, and we need to determine the area R, which is enclosed between x is 4 and x is 9, using integration. So the area R will simply be given by the integral from 4 up to 9 of 2x times x to the half. I'm writing the root x as x to the half minus 16 over x squared minus 6x plus 9. I will proceed in writing this in index form. So this gives me the integral from 4 to 9 of 2x to the 3 over 2 minus 16x to the minus 2 minus 6x plus 9 dx. Remember that when we integrate, we increase the power by 1 and divide by the new power. So this will give me 2 times x to the 5 over 2 over 5 over 2 minus 16x to the minus 1 over minus 1 minus 6x squared over 2 plus 9x, and I'm integrating between 4 and 9. Before substituting the limits, I will simplify the expression. So this is 4 over 5 x to the 5 over 2 plus 16x to the minus 1 minus 3x squared plus 9x between 4 and 9. I will substitute the upper limit, leading to 4 over 5 times 9 to the 5 over 2 plus 16 times 9 to the minus 1 minus 3 times 9 squared plus 9 times 9. That's the upper limit substituted. minus the lower limit, so 4 over 5 times 4 to the 5 over 2 plus 16 times 4 to the negative 1 minus 3 times 4 squared plus 9 times 4. Plug this on the calculator, we get an answer of 746 over 45 squared units for the area R. In question 3, we're dealing with an arithmetic series having the sixth term being 11 and the sum of the first three terms being negative 15. And we need to show that the first term is negative 9 and then calculate the common difference. Well, let me start by reminding you that the nth term of an arithmetic sequence is given by a plus n minus 1d, whereas the sum of the first n terms is given by n over 2 times 2a plus n minus 1d. We know that the sixth term is 11, so we've got that u6 is equal to a plus 5d, and this is equal to 11, whereas the sum of the first three terms will be 3 over 2 times 2a plus 2d, and this is equal to negative 15. I can expand this to get 3a plus 3d is negative 15, and therefore I can divide everything by 3 to get a plus d is negative 5. We already have established that a plus 5d is equal to 11, so I can subtract one from the other, so to eliminate a, leading to 4d is equal to 16, and therefore d is equal to 4, and I can proceed by substituting back to find the value of a. So going back to a plus 5d is equal to 11, we've got that a plus 5 times 4 is equal to 11, and therefore a plus 20 is 11, leading to a being negative 9 as required. In part B, we're given that Sn is greater than 888, and we need to determine the least value of n, so we need to solve this inequality here. I will start by substituting in the formula for the sum of the first n terms. We've got n over 2 times 2a, a was found to be negative 9, plus n minus 1 times the common difference of 4, and this is greater than 888. I will expand to get n over 2 times minus 18 plus 4n minus 4 being greater than 888, which leads to n over 2 times minus 22 plus 4n is greater than 888. So I will further expand to get that minus 11n plus 2n squared is greater than 888, and therefore we've got that 2n squared minus 11n minus 888 is greater than 0. We're dealing with a quadratic inequality. I will use the quadratic formula to determine the critical values, because I would not attempt this through factorization because the numbers are quite big. So the critical values are given by n is minus b plus minus b squared minus 4ac all square rooted and over 2a. So plugging this on the calculator gives me the critical values for n being 24 and minus 18.5. If I quickly draw my parabola with the critical values, I can see I go plus, minus, plus. Remember, we want to be greater than 0, so we want to be in the plus side, so either to the left or right. So we want n to be less than minus 18.5 or n greater than 24. But remember that n has to be a positive integer, so the first value for n that lies within the solution set is n being 25. In question 4, we've got a sketch of the curve with the given equation, and we need to determine the set of values of x for which f of x is decreasing. Well, decreasing means that the first derivative f dash of x is less than or equal to 0, or we could also use a strict inequality. And practically what this means is that I'm trying to determine the values of x for which, when I draw my curve from left to right, I go down. So essentially we need to determine these two values of x here and here. and obviously these are the values corresponding to the stationary point, so dy dx is 0. So let's start by considering f dash of x. When we differentiate, we get the power down and we deduct 1 from the power. This leads to 2 times 3x squared plus 3 over 2 times 2x minus 18, which simplifies to 6x squared plus 3x minus 18. If I set this equal to 0, I will divide first by 3 to get 2x squared plus x minus 6 is equal to 0, which factorizes into 2x minus 3 and x plus 2. This gives me values for 2x minus 3 is 0, or x plus 2 is equal to 0. And therefore I've got 2x is 3, which means that x is 3 over 2, or x is negative 2. Going back to my diagram, the negative 2 is here, the 3 over 2 is here, and I can easily conclude that my function, my f of x, is decreasing between minus 2 and 3 over 2, and therefore we conclude minus 2 less than or equal to x less than or equal to 3 over 2. You could have used strict inequalities and that would be perfectly acceptable by the examiner. We're then told that the equation f of x is k, where k is a constant, has one real root, and we need to find the set of values for k. So we are essentially looking at a horizontal line, the line with equation y is equal to k, and we're trying to determine the number of points of intersection. So you can easily see that for a point of intersection only for one real root, we need to be above the maximum point here and below the minimum point over here. So I will start by determining the corresponding y values at x is negative 2 and at x is 3 over 2. So f of minus 2 is equal to 2 times minus 2 to the power of 3 plus 3 over 2 times minus 2 squared minus 18 times negative 2 plus 3, which gives an answer of 29, whereas for 3 over 2 we get f of 3 over 2 is 2 times 3 over 2 to the power of 3 plus 3 over 2 times 3 over 2 to the power of 2 minus 18 times 3 over 2 plus 3, which gives an answer of minus 111 over 8. So we can see that for the maximum point it has a y coordinate of 29, whereas for the minimum point it has a y coordinate of minus 111 over 8, and therefore we conclude that k has to be greater than 29 or k must be less than minus 111 over 8 for f of x is k to have a single real root. In 5, we've got an expression for f of x here, and we are told that the remainder when we divide by x plus 2 is negative 24, and we need to use the remainder theorem to show that a is minus 32. Well, we know that the remainder when f of x is divided by ax minus b is given by f of b over a, which in our case simply means that f of minus 2 should be minus 24. This leads to minus 24 is minus 2 to the power of 3 minus 8 times minus 2 plus a, and therefore we obtain that minus 24 is equal to 8 plus a, leading to minus 32 is equal to a as required. We are then told that x minus 4 is a factor of f of x, and we need to write f of x as a product of two algebraic factors. So we have already established that f of x is x cubed minus 8x minus 32, and I will proceed in long dividing by x minus 4 to split this into a product of a linear and a quadratic expression in x. So notice that I've put a 0x squared term as a placeholder when I do the long division to have all the like terms below each other. So we're trying to eliminate the highest order term found on the left hand side. So I'll be multiplying x by x squared to get x cubed minus 4x squared. I'm deducting, leading to 4x squared minus 8x minus 32. I will then multiply by 4x to give me 4x squared minus 16x, and again I deduct, leading to 8x minus 32, and I will now multiply by 8 to get 8x minus 32, and if I deduct, I get the remainder of 0 as expected because x minus 4 was a factor. This means that we can write f of x as being the product of x minus 4 and x squared plus 4x plus 8. In II, we need to prove that f of x being 0 has only one real root. So we've got x minus 4 times x squared plus 4x plus 8 being equal to 0. So either x minus 4 is 0, which means that x is 4, or x squared plus 4x plus 8 is equal to 0. Well, remember, we're trying to show that there's only one real root. We have already found one such root, being the x is 4. So the intention is now to show that these will yield no real roots. And I will do this by considering the discriminant, the b squared minus 4ac. So the discriminant here is 4 squared minus 4 times 1 times 8, which gives an answer of negative 16. I explicitly compare this with 0. Since this is negative, we conclude that we have no real roots from this quadratic in x, and therefore there is only one real root, the value of x being 4. In 6a, we are asked to sketch the curve with the equation y is a to the x, where a is greater than 1. We need to clearly show the coordinates of any points of intersection with the coordinate axis. Well, if I draw my axis here, I know that the graph of a to the x starts from the very low on the left-hand side and takes off towards the right-hand side, cutting the y-axis at 1, because when I'm cutting the y-axis, x is 0 and a to the power of 0 is obviously 1. In part B, we need to use a trapezium rule with all the values of y in the given table here to obtain an estimate for this integral. So the trapezium rule, remember, it's a way of estimating a given integral. So it always starts with a half times the height of the trapezia, which is the difference between two consecutive values of x in the given table. So that's 0.4 in our case, and then it's the first and last y values once, and all intermediate values twice. So 2 times the 16.37 plus the 24.47 plus the 36.83 plus the 55.80. I plug this on the calculator, I get 72.588. Remember, I need to give my answer correct to one decimal place, so this rounds to 72.6. And then in C, we need to use the answer to part B to obtain an estimate for the integral of 3 to the x plus 1 plus x from 2 to 4. So what I will do is I will start by writing this as the integral from 2 to 4 of 3 to the x times 3 to the 1 plus x dx, which can be written as the integral from 2 to 4 of 3 times 3 to the x. And I will write the x as 3x minus 2x with respect to x, and we will see why in just a moment. So this can be written as 3 times the integral from 2 to 4 of 3 to the x plus x. So by writing x as 3x minus 2x means I've got a common factor of 3 here. So the 3 came out and I'm left with 3 to the x plus x dx, which is exactly what I have estimated using the trapezium rule in part B, minus the integral of 2x with respect to x from 2 to 4, which I can carry out analytically. So this is approximately 3 times the 72.6, the answer to part B, minus 2x squared over 2 from 2 to 4. Now obviously the 2 will cancel out, and what I obtain is 217.8 minus the 4 squared minus the 2 squared, which gives a final answer of 205.8. In question 7i, we need to find in terms of log 3 base 2 an exact solution to the given equation, and I will start this by writing a to the x as a power of 2. So we've got 3 times 2 to the x minus 2 is equal to 2 cubed to the 8 times x, which means that 3 times 2 to the x minus 2 is 2 to the 3x, which leads to 3 is 2 to the 3x over 2 to the x minus 2. Well, we know that when we've got a division with a common base, we subtract the indices, so this leads to 3 is 2 to the 3x minus brackets x minus 2, and therefore 3 is 2 to the 2x plus 2. I can now take log base 2 of both sides, which leads to log of 3 base 2 is equal to log of 2 to the 2x plus 2 base 2, and therefore log of 3 base 2 is 2x plus 2 times log 2 base 2. Well, we know that log of 2 base 2 is simply 1, and therefore we get that log of 3 base 2 minus 2 is 2x, which means that log of 3 base 2 minus 2 and all of it over 2 is equal to x, which is the exact solution to the given equation involving log of 3 base 2. In II, we need to solve using algebra the given logarithmic equation, explaining clearly why there is only one solution, and I will actually start by investigating the restrictions we have on y. We need 2y plus 1 to be positive and 2 minus y to be positive, because the logarithm is only defined when the input is positive. So I will start by stating that any solution for y should satisfy these two conditions we just outlined. So we want the 2y plus 1 to be greater than 0 and the 2 minus y to be greater than 0, which means 2y is greater than minus 1, so y is greater than minus a half, and 2 being greater than y, which means that we want any value for y to be a solution, should be between minus a half and 2. I will then proceed by solving the given logarithmic equation, and I will apply the power law, which says that the 2 can go up as a power. So we've got log of 2y plus 1 to the power of 2 base 5 minus log of 2 minus y base 5 is equal to 1. Now we've got log minus log to the same base, so this can be written as log of 2y plus 1 squared over 2 minus y base 5 being equal to 1, which means that 2y plus 1 squared over 2 minus y is equal to 5 to the power of 1, which leads to 4y squared plus 4y plus 1 is equal to 5 times the 2 minus y. I'm cross multiplying, so we obtained 4y squared plus 4y plus 1 is equal to 10 minus 5y, and if I collect everything on the left hand side, this gives me 4y squared plus 9y minus 9 is equal to 0, which factorizes into 4y minus 3y plus 3 is equal to 0, and therefore 4y minus 3 is 0, or y plus 3 is equal to 0. We get 4y is equal to 3, so y is 3 over 4, or y is negative 3. Well, remember we had the restriction that y should be between minus a half and 2, and therefore the y is negative 3 has to be rejected. We say it's not valid, so we are only left with one solution as expected. The y is 3 over 4. In question 8, we've got the depth of water d meters in a harbor on a particular day being modeled by this equation here. T is the number of hours after 5 o'clock in the morning, and the angle is measured in radians. We need to show that the depth of the water at 6 o'clock in the morning is 2.4 meters. Well, since we are measuring from 5 o'clock in the morning, then at 6 o'clock in the morning, t is 1. So we've got that when t is equal to 1, we have that d is 3 minus 1.2 sine of pi over 6, which if you plug on the calculator, you get 2.4 meters as required. In part B, we need to state the greatest value of d, and starting with the expression for d, we know that sine of any angle varies between plus minus 1, and therefore the 1.2 sine will vary between plus minus 1.2, so we can easily conclude that the maximum value for d, the maximum depth, will be 3 plus 1.2, which is 4.2 meters. In part C, we need to find the first 2 times of the day after 5 o'clock in the morning that the depth of the water in the harbor is 3.5 meters, and we need to give our answers to the nearest minute. So essentially here we're being asked to solve 3 minus 1.2 sine of pi t over 6 being equal to 3.5. This leads to minus 0.5 being equal to 1.2 sine of pi t over 6, which leads to minus 5 over 12 being sine of pi t over 6. I will start by finding the principal value, which is shift sine of minus 5 over 12. So if I go on my calculator, I'm in radian mode, I'll do shift sine of minus 5 over 12. This gives an answer of minus 4297 ... So minus 0.4297 ... which I will store on A on my calculator. So I press the STO button and A, and I can then proceed using the generating formula to find the values for t. So we've got pi t over 6 being equal to the PV plus 2 pi k, or pi t over 6 being equal to pi minus the PV plus 2 pi k, which leads to t is 6 over pi times a plus 2 pi k, or t is equal to 6 over pi times pi minus a plus 2 pi k. Now that I have stored the principal value on the a key, I can use my calculator to generate the solutions. So in f of x, I'll put 6 over pi times the a, so alpha a plus 2 pi x, and I close bracket, that's the f of x, and for the g of x, I'm going to put 6 over pi times the pi minus the a plus the 2 pi x. So the x in this case plays the role of the k. So I press the equal button. I will set my start to be at 0, my end to be at 5. I'm stepping every one. So essentially, I'm automating the whole process of generating the solutions. So I press the equal button. I got all solutions here. Remember that the value of t varies between 0 and 19, and I'm only looking for the first 2 positive solutions. So I see one of them is 6.8208, and if I press the button above the E and G, this will convert this into hours and minutes and seconds. So this is 6 hours, 49 minutes, 14 seconds, and so on. So I see that t is 6 hours 49, and if I go to the left and down, the 11.179 into hours and minutes is 11 hours 10 minutes 45 seconds. So to the nearest minute is 11 hours and 11 minutes. Remember, these are hours after 5 o'clock in the morning, so I can easily conclude that if we're talking about 6 hours 49 minutes after 5 o'clock in the morning, then we are obviously talking about 11:49 in the morning. And for 11 hours 11 minutes after 5 o'clock in the morning, then it's the 16:11, so 4 in the afternoon and 11 minutes. In 9a, we've got the first 3 terms of a geometric series being sine theta cos theta and a half. Theta is a constant, and we need to show that this leads to the given trigonometric equation. Well, we know that the characteristic of a geometric series is that the consecutive terms are in the same ratio, which means that u3 over u2 is equal to u2 over u1. So in our case, we've got a half over cos theta is equal to cos theta over sine theta. I will cross multiply to get 0.5 sine theta is equal to cos square theta. I can multiply throughout by 2 to get sine theta is equal to 2 cos square theta. And then I'm going to use the identity that says that the sine square plus cos squared is 1, which means that cos squared can be written as 1 minus sine square theta, leading to sine theta is 2 minus 2 sine square theta. and I will collect everything on the left hand side to get 2 sine squared theta plus sine theta minus 2 is equal to 0 as required. We then have that theta lies in the interval of 90 to 180, and we need to find the value of theta correct to 1 decimal place. I will start by applying the quadratic formula to find values for sine theta. So it's minus b plus minus b squared minus 4ac or square root and all of it over 2a, so 2 times 2. This gives answers for sine theta of minus 1 plus root 17 over 4, the first one, or the second one, which is minus 1 minus root 17 over 4. Well, this is actually equal to minus 1.28, and therefore we reject this. It's not valid because we know that sine of any angle has to be between minus 1 and 1. So I will proceed with sine theta being minus 1 plus root 17 over 4. I will find my PV by doing shift sine of this, minus 1 plus root 17 over 4. This gives an answer of 51.331 ... So we know that theta is the PV plus 360k, or theta is equal to 180 minus the PV of 51.331 ... plus 360k. Since theta is between 90 and 180, we conclude that theta is 128.7 by setting k to be 0 in the second formula. In part C, we need to prove that the series is convergent, and to do that I will start by finding the values for u1 and u2. So u1 is sine theta, which is equal to sine of 128.7, which gives an answer of 0.780 ... whereas u2 is cos theta, which is cos of 128.7, which gives an answer of negative 0.6248 ... Well, the common ratio of a geometric sequence is u2 over u1, so in our case it's minus 0.6248 ... over 0.780 ... which gives an answer of negative 0.800 ... And since the value we have found for r lies between minus 1 and 1, we conclude that the series is convergent. We need to make the comparison with the 1, so the absolute value of y is less than 1, and this simply means that subsequent terms are smaller in size, and therefore we say that the series is convergent. In part D, we need to find the value of the sum to infinity correct to two significant figures. Well, let's recall that the sum to infinity is a over 1 minus r, where a is the first term and r is the common ratio. So in our case, the sum to infinity will be the sine over 128.7 ... the first term of the sequence, over 1 minus the negative 0.800 ... This gives an answer of 0.4337 ... which correct to two significant figures is 0.43. In question 10, we've got the circle centered at C. We've got points P and Q with the given coordinates lying on C, and we need to determine the equation of the straight line L, which is the straight line passing through the center and the midpoint of PQ. So we know that this angle here should be a right angle because the angle passing through the midpoint of a chord and the center of a circle should be perpendicular to the chord. So to find the equation for L, I will start by finding the gradient of PQ. I'll be doing rise over run, so negative 6 minus 6 over the 10 minus 4, which gives an answer of negative 2. And we conclude that the gradient of L should be a half. I flip and I change the sign because they are perpendicular. I will then proceed in finding the midpoint of the chord PQ. And remember, the formula for the midpoint is x1 plus x2 over 2, comma y1 plus y2 over 2. This gives an answer of 7, 0. These are the coordinates of the midpoint of PQ of point M. And we know that for a straight line with gradient m passing through the point x1, y1, the equation is given by y minus y1 is mx minus x1, and therefore we obtain y minus 0 is a half brackets x minus 7. I will cross multiply to get 2y is equal to x minus 7. And I collect everything on the left hand side to get 2y minus x plus 7 is 0, to match the form in which the question was asking us to give our equation of the straight line. We are then told that the y-coordinate of the center is -2, and we need to determine an equation for the circle. Well, I will use the fact that the center of the circle lies on the straight line L, so when y is -2, I will substitute into the equation we just found for L. So 2 times -2 minus x plus 7 is 0, leading to minus 4 minus x plus 7 is 0, and therefore we get that 3 is equal to x, and therefore this means that the center of the circle has coordinates 3, -2. I will then proceed in finding the radius. I'll be doing the distance formula. I've got the center, I've got 2 points lying on the circle. I'm going to pick one of them. So if I just pick point P with coordinates 4, 6, I will find the distance CP, and that will be my radius. So I'm doing y2 minus y1 squared, so 6 minus -2 squared plus x2 minus x1 squared, so 4 minus 3 squared and all square root. This gives an answer of root 65. This is the length of the radius. And using the fact that the circle centered at the point alpha beta having radius r has equation x minus alpha squared plus y minus beta squared is r squared, I can simply substitute to get x minus 3 squared plus y minus -2 squared is equal to root 65 squared, which can be written as x minus 3 squared plus y plus 2 squared is equal to 65.